guys, welcome back to another video. And in today's video we are gonna solve the question Leetcode-198, which is house robber. It is a 1D DP problem. First of all, I'll just read the problem statement. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. Only constraint stopping you from robbing each of them is the adjacent houses a security system. Not even contact. Okay, so I'll just explain you what the question is. Basically, basically, there is a robber, and robber can only there is a condition, there is a constraint that if for example robber is robbing this house, then it can't go to this house and it can't go to this house. Okay, for example, if the robber goes to the first house, then it can't rob this house. It have to skip this one and go to this one. And if the robber is robbing this house, then it can't rob this house or this house. Basically, whichever element the we are picking, we have to skip the adjacent elements, right? So so I think this is very clear, the problem statement. Now I'll just proceed towards the solution. What we are going to do is, it's a classical 1D DP problem. First, we'll initialize an DP. We'll initialize a DP of size 1, 2, 3, 4, 5. Okay, minus 1, minus 1. Okay, this is what we initialized, right? Now, now, now the base case. Now the base case will come here. First of all, first of all, DP0. This is 0, 1, 2, 3 and 4. Okay, we are using a zero based indexing. And dp0, what will we put in dp0? Once again, yeah, here we'll put this guy. Okay, so basically instead of minus 1, here it will be 2. Okay, and the main crux is here of this guy. What will we put here? Should we put 7? Should we put 7, or we should put the max of this? Now this thing, I because this thing is a bit hard to get intuitively, so I'll show you the both cases. I'll just code it down and then I'll show you what we have to do. Okay, just stay with me, guys. Basically, right now, if I tell you, we will put the max of in dp1. What we'll do is, we'll put the max of dp0 and dp1, and the rest will be minus 1, minus 1, and then we'll iterate through. Okay, we'll put the max. We will not put dp1. Why max? Because, for example, if our dp is like this, oh sorry, if our array is like this, the first house has money 7, and the second has this 2. So when we are returning, we will actually return dp n minus 1. Okay, so if we return dp n minus 1, it will return 2, which is wrong. We want this. So what we'll do is, when we are making a dp, will dp1 will make it the max of dp of 0 and 1. Let me just code it down and then I'll explain. Okay, yeah. So first of all, the base condition, step 1 is basically, if n equals to 1, if n equals to 1, if n is, what are the constraints? Okay, 1 to this. Okay, then return nums of 0. Now we'll make an array, dp array of minus 1 into n plus 1. What we are doing here is, this is basically a dp state. We have made an dp array of minus 1, of minus 1 minus 1 minus 1 till n times, right? Wait. Yeah. Now dp0 equals to nums of 0 and dp1 equals to max of nums of 0 and nums of 1. Now we'll loop for I in range 2 comma n, and now the transition state of a dp, this dpi equals to max of dp I minus 1 comma dp I minus 2 plus nums of I. To explain this step, why I wrote this, I'll just explain you. I'll take this example now, right? Now we actually want the maximum. We want the maximum. Uh, we want the maximum robbery. Okay, so basically, if we select this house, okay, if we select this house, then we'll go to this one. 2 plus 9 is 11. Then we go to this one. Okay, so if I just write it down, 2 plus 9, and then this. So this is 2 plus 9 equals to 12. Okay, now what if I took, what if I did go from here and then here, and in this case the maximum will be, what will the maximum will be 10, right? So can you see the sub problem? Can you see the sub problem? Basically we are taking the maximum of dp I minus 1 of this guy, and if we are taking the maximum of this guy, and now we can't choose this element, we have to choose this element, right? So if we are basically if we are going behind two steps, then we can add the nums I, otherwise we can't take this line. Okay, so basically what we are doing in a transition state is we are taking the maximum of dp I minus 1 and dp I minus 2 plus nums of I. For example, if we have dp if we have an array like this, now what's the case? Now the answer would be 4, because our robber will go and take money from this house, and then he'll take from this house. In order to get this, we'll again establish a dp state, and we'll skip this one. We'll skip this one too, because this this guy is already greater. Is already greater. Let me just, if we make a dp array. Wait, I'll explain you this example too. Of minus 1 comma minus 1 comma minus 1 comma minus 1. Okay, now we establish a dp, this is a dp state. Now what we are going to do is, we'll take the first, and we'll take the maximum of these guys, which is 2, then it's minus 1, then minus 1, and then we'll iterate from, it is 0, 1, 2, and 3. if we are on 2 if we are on 2, we'll take the maximum of, dpi and dpi minus 2 plus nums of I. So what is nums of I here at second? It's 1. So we'll just cut it out and we'll write 3. Okay, now we'll go on to this guy. Okay, Now we'll take again, we'll do the maximum of dpi minus 1, which is 3, comma dpi minus 2, which is 2, which is this guy, 2, plus the nums of I, and it's 2, so 4. So we'll return dp of n minus 1. I hope this example is clear, because this is also an example which is not covered in the test cases. Okay, now what we are gonna do is, uh, I'm going to 1, and let me just take it on here. Yeah, it should work. Yes. Yeah. Now, what is the time complexity and what is the space complexity? The space complexity is here. Here it is O of n, right? The space complexity is O of n, because we have made a whole DP array. Okay. But can we reduce this? Can we do it in O of 1? Yes, we can. How? If we initialize two variables, wait, prif2 equals to nums of 0 and prib1 equals to max of, yeah, one here, and prib2 and prib2 equals to prib of 1, and prib of 1 equals to curr. Let's see if it works. uh, we got an error here. Yeah, 2 comma n. uh, yeah, so we just solved this question in the space complexity of O of 1. Okay, I hope this question is very much clear to you, and if you have any doubt, then please type your doubt in the comment. Thank you guys.